Okay, dear students, today let us start one more new concept. Actually, not a new concept. We have discussed yesterday about this what expression for equivalent focal length. Okay, two thin lenses kept in contact. Okay, one second. Now we know thin lens is one. One second, let me check the. Okay, no problem. Thin lens is one where its thickness, its thickness is very small as compared to its radii of curvature, its radii. Imagine there are two thin lenses kept in contact. Okay, then what will be that effective focal length is a question. Today let us study the same thing. Okay, see, let us consider two thin lenses, lens 1, lens 2, okay, of course thin lenses, lens 1 and lens 2, okay, fine, okay, like this is principal axis and okay, a ray of light, let this be point object, say O. A beam of light is incident on first lens, say L1, from point object on principal axis. Of course, it undergoes refraction by first lens L1 and also second lens L2. Finally, the ray will reach point R. They will reach point R, where real inverted image is formed. The real image is formed. This object is placed beyond the focus. Now, what you are supposed to imagine here? Remember, in the absence of lens L1, your ray would have traveled this distance. Say when this L2 is not present. In the absence of second lens, this will be the path traced by your incident ray, and this will be the position of final image. Let's do in the absence of lens L2. Hope you understood. Let me repeat. Let us consider two thin lenses placed in contact. Let O be the object placed at a distance O at a distance U from a common center, optical center. A ray of light will undergo refraction by lens L1 as well as lens L2. No problem in that. Okay, fine. After refraction by these two lenses, finally it will form image at I. Let this be image distance, say V. In the absence of, suppose that this lens L2 is not present, then this will be the ray, refracted ray traced after refraction. And V1 let be the distance of this image formed in the absence of what? In the absence of first lens. It's very simple one, but at the same time very important. By mass derivation, very important. How to derive this? Simple. We know, let me start here. We know by thin lens formula, we know by thin lens formula what? 1 by V minus L. L1 as well as L2. Okay? It's showing 1 second. Next. L1 and L2. Just we have to consider refraction. Refraction by lens L1. Refraction by lens L1. 1 second. Refraction by lens L1. No problem. What we have to write? This is the lens formula. We have to extend this formula for first lens. Refraction by lens L1, of course, in the absence of lens L2. What we have to do? We have to express this formula when lens L2 just lens L1. Okay, in the presence of lens L1. So now we can write 1 by V, where V is image distance. Here I can write 1 divided by V1. See here, in the absence of lens L2, image is formed at I1, which is at a distance V1. Hence, formula will be what? 1 divided by V1. Very simple. Minus 1 divided by object distance U. Of course, we have taken object distance as U. No problem. Let me write 1 by U. Okay. Here, let F1 represent focal length of first lens L1 and F2 represent what? Focal length of second lens. We have to declare it. In the beginning of the explanation, what we have to write? Let us consider two few lenses of focal length F1 and F2. If F1 is the focal length of first lens, then have it as F1. Say equation 1. Fine? No problem. Okay. Now, this is equation 2 actually. Please remember, we have taken this as equation 1, standard equation 1. Now, this will be equation 2. Now, refraction by lens L2 or refraction to lens L2. Of course, refraction through lens L2 in the absence of L1. You have to remember. Refraction through lens L2 when in the absence of L1. If L1 not present, then just leave this part. What we have? Only this much. Remember, in this case, your I1 acts as virtual object. I is a real object. I mean, real image formed at I. Let me repeat. In the absence of L1, refract or in the absence of L1 for refraction to L2. What we have to imagine? We have to consider I1 as a virtual object. This virtual object produces image at I. Then how to write this equation? See, 1 divided by image distance. Here, final image is I and image distance is V, 1 by V minus. What about object distance? C is I1 acts as a virtual object. Hence, 1 divided by V dash is equal to, what about focal length? Of course, we have taken focal length as F2. This is equation 3. Hope you understand. Equation 3. Very simple. What next? Just add equation 2 in. What we get? Like somewhere here I will write. Okay. Here, see, adding equations 2 and 3. Adding equations 2 and 3. Let me add literally 1 by v dash minus 1 by u plus 1 by v minus 1 by v dash is equal to 1 divided by f1 plus 1 divided by f2. Correct? This equation we get 1 by v dash minus 1 by u plus 1 by v dash 1 by v minus 1 by v dash. Now you can cancel these things. Correct? You can cancel it. So here. Okay? I will write 1 by v first, no problem. Correct? 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f2. This is the final equation we get. Then fine. Correct, no problem. Now, if we replace, please listen carefully. If we replace these two, sum of these two lenses by equivalent lens, by an equivalent lens of focal length f. Let me repeat. If we replace these two lenses by equivalent focal length, a lens of equivalent focal length, say f, then we can definitely write 1 by v minus 1 by u is equal to 1 by f. Thin lens formula for that combination. Correct? Okay. Say this is equation 4, and this is equation 4, and this is equation 5. Now, from equations 4 and 5, of course we can write what? Equating these two here, 1 by f is equal to 1 divided by f1 plus 1 divided by f2. This is required equation, very simple equation, required equation for equivalent focal length of two thin lenses kept in contact. We can extend this in contact. So I write this as 1 by 2 is equal to 1 by f1 plus 1 by f2 plus 1 by f3, okay, plus n number. Similarly, for problem solving, please remember this 1 by f is nothing but p. So, what is p? Power of plus. P is equal to what? P1 plus P2 plus P3 plus S. In terms of power, also we can express. Okay, hope you understood. Very simple equation. Fine? Okay. If you understood this point, without wasting time, let us continue to one more new concept. Okay. Name of the concept is refraction through prism. Refraction through prism. What is prism? What is prism? In your high schools, you have seen prism, right? The prism is used to what? Just to disperse when a composite light is allowed to fall on any one surface of the prism. We get what? With pure. Correct? A composite light is what? Divided into 7 different colors. Here, what we have to do, next concept. In next concept, we have to derive an expression where we have to connect refractive index. Please keep in mind what we have to connect. We have to connect the refractive index of a prism to its angle of prism and angle of minimum deviation. There are two terms I am using. Express refractive index of a prism in terms of angle of prism and angle of minimum deviation. Very important 5 marks derivation in this chapter. Probably this is last 5 marks derivation in this chapter. This is last 5 marks derivation. This question directly as derive an expression for refractive index of a prism, material of a prism in terms of angle of prism and angle of minimum deviation or problems on that. Problems on this concept. Please remember. Then we have to solve problems using log table, all those things. Okay? We will discuss it later. First, let us see what is prism. Okay. Let me draw a prism. Three-dimensional. See, P, Q, R, S, T, U. Okay. This is prism. Correct? What is prism? Simple. Prism is an optical medium. First, prism is an optical medium bounded by three rectangles. Have the rectangles P, Q, R, S. Let me repeat. P, Q, R, S. First one. Q, T, U, R. Second one. Q, T, U, R. Second one. PTUS. It's bounded by three rectangles and two triangles. Two triangles. Two triangles. A prism is an optical medium bounded by three rectangles and two triangles. These triangles are parallel to each other. These triangles are parallel to each other. What we do usually, we consider principal section of a prism. Imagine we cut a slice of the prism. Okay, having some rough surface. It's not used for refraction purpose. Rough surface base. This is called angle of prism. Say ABC. Usually write ABC. This angle is called angle of prism. We have two refracting surfaces here. Surface AB, surface AC. When ray of light is incident on any surface, say for example AB, and if you draw a normal, here ray of light is traveling from rarer to denser. Automatically we observe bending of light towards the normal. If you draw one more normal, a second surface, say AC, then once again there is refraction. What refraction? Between denser to rarer. Here rarer to denser, here denser to rarer. The ray will emerge like this. This ray is called usually incident ray, refracted ray, and emergent ray. This is the emergent ray. And how do we represent angles? See. With respect to this angle, this is angle I, correct? This is angle of refraction, expressed surface R1. This is angle of incidence. Let me show angle of incidence on second surface. But while deriving the derivation, we represent it by R2. Here, angle of incidence we take as R2, not I2. Why? Let us discuss. This angle, once again, from denser to rarer, this angle of refraction we represent it as angle of emergence E. For this emergent ray, angle of emergence E. See, for a prism, there is some principle called principle of homogeneity, principle of reversibility, principle of reversibility. A ray is allowed to travel in this fashion, will retrace its path exactly. Imagine if you hold some mirror or like that. If you hold some mirror or like that, or you can trace ray exactly backwards. Forward direction is exactly equal to backward direction. If it is a backward direction, then this is angle of incidence, this will be angle of refraction. There is no hard and fast rule like the angle of refraction here, especially in case of prism, we can take angle of incidence as R2. Don't confuse. Here most of here they have some confusion while taking angle of incidence at second surface. Let R2 represent angle of incidence at second incidence. By principle of reversibility, you can take R2. No problem. Okay? Fine. Now, what is a prism? Prism is optical medium bounded by three rectangular surfaces and two triangular surfaces. Okay? Now, see, derive is the angle of minimum deviation medium. This is a question. Remember, most of the students, or at least some students, face problem in reading questions, understanding questions, and writing the correct answer. They just what? They just oversight the question, and write whatever answer they know. Please remember, we usually say n to 1 or n is equal to sine I plus df by divided by 2 or sine k by 2. Simply we say, but question will be in this form. Derive an expression for refractive index of material of a prism in terms of angle of prism and angle of deviation. This is, once again, let me write, very important for finding marks. You have to practice it more and more. You have to practice it. Okay? Anyway, I will rub this question because almost covered my board. Okay? And the derivation is quite big. So I have to rub this. Please remember. Okay? Hope it's better if you know the things while listening to the lecture instead of just watching like a movie. Okay? Simply looking at the mobile like lying on the bed with a lazy position, all those things will not help definitely. What you have to do? You have to take pen and paper, make the note whenever necessary. Make the notes whenever necessary. This will be helpful. Anyway, you are almost half year completed now. Okay, you have to start studying now. Anyway, you have to write main exam, CET, JE, number of exams waiting for you. Please remember, be serious, don't waste time. Okay. Now, let us consider a prism okay. A ray of light is incident. Let PQ be ray of light. Let me draw a normal, or I will draw solid line only. This is to avoid confusion. Let me take it as x, y, z, and let us see base of the prism. After refraction, we know light will travel in this fashion, and let me draw one more normal here. Okay. Finally, see, this is PQ, this is R, and this is S. This is the emergent ray. This is emergent ray. Okay. In the absence of this prism, if this PQ is incident ray, would have taken this path, correct? This should be the path taken by this ray or straight line. It would have traveled straight line without any deviation in the absence of this prism. ಈ ಪ್ರಿಸಮ್ ಇಲ್ಲದೆ ಹೋಗಿದ್ರೆ ಈ ಬೆಳಕಿನ ಕಿರಣ ಏನು ಮಾಡ್ತಾ ಇತ್ತು ಹೀಗೆ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗ್ತಾ ಇತ್ತು ಬಟ್ ಡ್ಯೂ ಟು ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿಸ್ ಪ್ರಿಸಮ್ this will bend, it will refract towards the normal at surface xy initially from mirror to denser, then denser to mirror from surface xz second time, and finally it will take the path RS. Let this be A, angle of prism. Okay. Let me extend this line also. Okay. Let this common point be n. Okay. This x may you may get confused. X to n, no problem. I have no problem. Okay. With respect to normal, let me draw angle of incidence. Let me represent angle of incidence. Okay. Now, yes, no problem. Still moving. This angle will be angle of refraction from first surface R1. See, this is angle of incidence. We are representing it as R2. This is okay. With respect to normal, right? This is angle of emergence E. One second. Fine. This is E. So let me write the things. Let N1 be the refractive index of outer medium surrounding the prism. Small n to represent the refractive index of actual prism. Okay. What are things you noted? Somewhere here, visible, or here, see. I have written I, R1, R2, correct? And A, angle of prism, N1, refractive index of error medium, N2, refractive index of actual prism. These are things. Okay. I will draw this thing. Actually, as we discussed earlier, listen. In the absence of this prism, this is a path taken by incident ray. But due to presence of this prism, this incident ray, what? This incident ray refracted or emerged along RS. We observe this much of deviation produced. Let me represent deviation by delta. If it seems to be quite big, you can write here also, no problem. See? This is also delta, no problem. But show you, this will give you what? Delta. I will represent delta somewhere here only to avoid confusion. Okay, see here. This is the amount of what? Deviation produced. Here, we are representing deviation by delta. What? Let me repeat. Here, I am representing, actually, we are representing as given in textbook, what? We have to represent it by delta, better. Instead of the other six, delta is better. Delta. What delta represent? Total deviation produced due to diffraction of light at two different surfaces. What is deviation here? Deviation here is it is an angle between refracted with see the accident refracted okay and incident ray extended. Let me repeat. We observe here deviation produced due to diffraction of light by two different surfaces. What are two different surfaces? One surface is xy and other surface is xy. Due to these two surfaces, the actual path, this PQ will take RS. So much bending we observe, so much of bending observe. What bending? This is the actual path, straight line, and this is the bending. This angle, The angle between actual path and bending is called deviation. How to define now deviation? Deviation is defined as it is the angle between it is the angle between incident ray, extended and refracted ray. Let me repeat. Deviation is defined as it is the angle between incident ray, PQ, extended and refracted ray. Of course, we have to go back to get what? Deviation. Okay, this is delta. Let me write delta also. We have mentioned one more thing, delta. Correct? With this initial setup and explanation, what we have to do? We have to move into actual derivation. No problem, I feel, in this figure and whatever terms we have mentioned. Correct? Now, let me start. From quadrilateral, see carefully, X, Q, N, R. Let me take some different chalk piece. Okay, 1 second. Let us consider from quadrilateral X, Q, N, R. From this quadrilateral. This is normal. This is normal. You know, normal means perpendicular, 90 degree. This angle is equal to this angle is equal to 90 degree. This angle is 90 degree. This angle is 90 degree. For a given quadrilateral, sum of all internal angles will be equal to 360. If this is 90, this is 90, why? This is normal. See here, this is normal. We have got normal. We have got normal. Normal is perpendicular to the surface always. As this is perpendicular, this angle will be 90, this angle will be 90. No problem with that. In a quadrilateral, what? Sum of all internal angles is equal to 360. If it is so, then sum of these two angles means angle A plus angle QNR must be equal to 180 degree. Why 180 degree? It is already 90 minus 90. This plus angle A plus angle 90 plus angle N plus angle 90 is equal to 360 degree. These two angles are already equal, 90 are equal. Just use them. Anyway, you have to what? You have to subtract. Okay? You have to what? You have to subtract this. Correct? Now, if you add these two opposite angles, then A plus angle N, angle A plus angle N must be equal to what? Must be equal to 180 degree. Hope you understood. Very easy. Don't get confused. No confusion, right? This is equal to A plus given is equal to 180 degree. So equation 1. From, now see, from visible triangle I am writing triangle, remember triangle QNR. This is angle, this is triangle QNR. This triangle. What triangle? Let me change the color now. This triangle. This is triangle. Sum of all angles in a given triangle is equal to 180 degree. So I can write this is R1, this is R2. See, R1 plus R2, first angle, second angle, this will be third angle. What is third angle? Nothing but angle Q1 once again must be equal to 180 degree. This R1 first angle in a triangle Q1. Okay, please listen my word carefully. Triangle in a triangle Q1 R1 first angle, R2 second angle plus angle QNR is third angle is equal to 180 degree. So equation from equations 1 and 2, it is evident that RHS are equal. Right hand side of both the equations are equal. So I will write very neatly. I will take A, angle A as simply A, okay, for simplification purpose, plus angle QNR must be equal to R1 plus R2 plus angle QNR. Correct? Correct? No problem. We can cancel this QNR. Then what? Then R1 plus R2 is equal to A. Very important relation. The equation. Correct? If you have confusion is there, just go to the video once again. You will understand. Okay. Now, I will just rub these things, correct? No problem. Now, I have to write expression for deviation. Okay? What? Deviation produced. Deviation produced. Delta is equal to, see here, this is delta. This delta is equal to, in a triangle, this triangle, see, I'll just make it bold without expression. Okay, anyway, concept is important. That this figure, see, this is a figure. Okay, this is a delta now. This delta is exterior angle. What? This delta is exterior angle. And also delta is deviation produced. This delta is equal to sum of these two interior angles, opposite interior angles. This delta is equal to sum of these two interior angles, opposite interior angles. If this is I, see here, if this is I, this whole thing will be I. Why? Because they are vertically opposite angles. They are vertically opposite angles. If this is I, here already we have R1. But what about this angle? This is the angle we need. This angle we need. Correct? This whole angle is I. This is R1. This angle will be I minus R1. I will explain one more time. Please listen. This is delta. This is triangle. This delta is equal to this angle plus this angle. Set this angle. Let us denote this angle as x, this angle as y. This angle x and this angle as y. But at the same time, we have two rays. I mean, a normal and a ray. If this is I, this will be I. Vertically opposite angle will be I. Correct? This is already R1. So, value of this angle will be whole angle minus r is equal to what? I minus r gives you this remaining angle. X value of x. Value of x is equal to I minus r. R1 actually I minus R1. Plus y plus deviation produced is exactly equal to deviation produced by first surface plus deviation produced by second surface. Total deviation is equal to deviation produced by first surface and deviation produced by second surface. This is deviation produced by first surface. Deviation produced by first surface. Now I have to write deviation produced by second surface. Second surface is x dash. Second surface is x dash. So this is one. Now look here. We have this line and this line. If this is E, this will be E. Correct? This will be E. These are both angles. Correct? This is E. This is already R2. What about this angle? Y will be E minus R2. Y will be E minus R2. See, this is E. This is okay. Refracted ray. This is normal. This is E. Vertically opposite angle. This is also E. But already here we have R2. So this angle, see, this angle will be E minus R2. E minus R2. Correct? Or I will go and once again like this. This is deviation produced by first surface. This is deviation produced by second surface. This delta project total deviation. Delta project what? Total deviation. Okay. Now let me draw once again. Okay, we drawn everything, correct? Now I can write this equation as delta is equal to I plus E minus R1 plus R2, or delta is equal to I plus E minus E from equation 3. R1 plus R2 we have already derived as, okay, this is equation number 4. This is equation number 4. Correct? Okay, I have to complete it very fast. Okay, we are running out of time. It's already 49 minutes. 49 minutes, right? Okay, 50 minutes now. Now, where I write? I'll write somewhere here. See, we have two equations now. Equation 1, see, some equation like R1 plus R2 is equal to A. Second equation, delta is equal to I plus E minus E. Okay, this is equation 3, this is equation 4. Okay. Quickly, I'll explain something. You have to do one experiment in lab. Of course, optics experiment. Name of the experiment is angle of minimum deviation. Angle of minimum deviation, where you are supposed to use prism and draw deviation produced by prism for different values of angle of incidence. Let me repeat. In our physics lab, you have one optics experiment where you are supposed to draw a graph of angle of incidence versus angle of deviation. Okay, then you get a graph there where you have to calculate angle of minimum deviation. Very interesting and important practical. Okay, there we will explain you exactly what we have done. Here, for simplicity or to not make you what complex or very what we call it's very difficult such things, I will explain it very simply. If we draw, a graph of deviation versus angle of incidence, deviation versus angle of incidence, or angle of incidence versus deviation, what we observe? We observe a graph of somewhat this kind. A graph which is like your U, English U, somewhat U like, okay? Somewhat, not exactly. For every value of delta deviation, we have two values of angle of incidence. This one value, this one value. Okay. We observe somewhere here, somewhere here. This angle of incidence is equal to angle of emergence. Angle of incidence is equal to angle of emergence. This condition is called angle of minimum deviation. Angle of minimum deviation. I will explain you this much only for simplicity. What is angle of minimum deviation? Initially, if you plot a graph of angle of incidence versus angle of deviation, we observe as angle of incidence increases gradually. Let me repeat. As angle of incidence 10 degree, 20 degree, 30 degree, 40 degree, 50 degree increases gradually along x-axis. Okay. Angle of deviation decreases. Angle of deviation decreases gradually with increasing angle of incidence. Then what? This angle of deviation reaches some minimum value somewhere here. Reaches minimum value. This minimum value is called angle of minimum deviation. Angle of minimum deviation. At this point, angle I is equal to angle E. Angle I is equal to angle E. Or here, exactly this angle is equal to this angle. Angle I is equal to angle E. Angle I is equal to angle E. I and E are equal. Angle of incidence is equal to angle of emergence. Angle of incidence is equal to angle of emergence at this point. After angle of minimum deviation, if you increase angle of incidence, then the angle of deviation increases gradually. Hence, we get this kind of curve. Smooth curve. Can draw smoothly. Smooth curve we get. What is the condition? At angle of minimum deviation, this angle I will be equal to angle E, and refracted ray will be parallel to base of the prism. Very important condition. At angle of minimum deviation, refracted ray inside the prism will be parallel to base of the prism. Then we observe some symmetry. What we get? Angle of incidence will be equal to angle of emergence. Not only this, both the angles R1, R2 will be equal to R. This is a condition. You have to remember. And in our derivation, initially we have written what? We have to consider angle of prism A and angle of minimum deviation. Angle of minimum deviation is represented by dm. Here, instead of delta, here instead of delta we use dm, where dm represents angle of minimum deviation. At angle of minimum deviation, This condition holds true. I is equal to E and R is equal to R1 is equal to R2. We replace both the values by simply R. If you are familiar with these things, this graph is not very important. These conditions are important. If you remember these things, your derivation is over. Your derivation is over. Okay? Let me write at the angle of minimum deviation, at the angle of minimum deviation, delta will be equal to dm. We call delta as dm. Then I will be equal to E. R1 is equal to R2 is equal to R. Now we can change these equations. Instead of R1 and R2, let me write this equation as 2R is equal to A. Equation 5. Very important. Here, instead of IE, let me replace this E by one more I. So delta by dm. Look carefully this equation. Let me replace this delta by dm. Here already I have one I. Let me replace second E by one more I. So 2I minus E. Hope you understood. Let me repeat. This is delta. I replace it by delta m by this condition. Second, this is I. I replace this E by one more I plus I, 2I. This is minus and equal A. Or 2I is equal to A plus delta M. Just put A this side. Okay? A plus delta M. Or here let me write I is equal to A plus delta M divided by 2. This is one more important equation. Equation number 6. Equation number 6. This is equation number. Okay. This is fine. Correct. Instead of this, okay. I'll just stop this, right? No problem. No problem. This equation is important. Here, I just forgot to mention one more thing. It's 2R. What about R? R is equal to A by 2. This is equation number 1. R is equal to A by 2, I is equal to A plus B divided by 2. These two equations are very important. And we are almost there at the end of the what? Derivation. Without wasting time, let me write. We know n21 is equal to sin I by sin R. Snell's law. N21 is equal to sin I by sin R. Sin I by sin R. Where N2 is the factor index of this one. N1 is the factor index of error. Or N21 is equal to, let me put value of I on this equation, value of R on this equation. Hope you understand. Let me put now value of I from this equation 6. Value of R on equation 5. And hence I will write as N21 is equal to sin A plus dm divided by am sin A plus dm divided by 2 divided by sin A by 2. This is required equation, where N21 represents the factor index of second medium equation, first medium is equal to, according to Snell's law, sin A represents what? Angle of incidence, angle of prism, plus dm represents what? Angle of minimum deviation. This is the most required equation. This is a required final equation. Okay, hope you understand. Okay, thank you for watching this video, and please go through these two derivations more often. It will helpful.